Okay, so I'm ecstatic to be able to welcome Dr. Terrence Stewart to the class today for this last lecture in the course. We're going to be talking about fairness. Dr. Stewart is a really a true leader in the field of artificial intelligence, and not just AI, but he also is a leader in cognitive science, computational neuroscience, and neuromorphic engineering. He's been a pioneer in each of these fields and the intersection between them. To make sure I get all the background information correct. Dr. Stewart is a senior research officer at the National Research Council of Canada, which is Canada's largest.
So the only government lab.
Oh my God.
Okay. Yeah. The US has a bunch of government labs. We have one. We consolidated it all together.
Yeah. The government lab of Canada. And so among the many hats that he wears is spearheading efforts to support the ethical and safe use of AI. This ranges from advising as well as setting up infrastructure to setting up third-party evaluations of AI models. He also plays a pivotal role in Canada's AI safety landscape. So he helped launch the Canadian AI Safety Institute, and just got back from the UK.
San Francisco.
San Francisco.
But it was actually run by the UK AI Safety Group, so it was confusing.
Okay, sorry. So where he represented Canada in these international discussions on the applications of AI. Dr. Stewart's had a remarkable journey to get to where he is today. He did his engineering degree right here in systems design engineering right here at the University of Waterloo. He then went on to get a master's degree from the University of Sussex, where he worked at the intersection of psychology and experimental products. He then came back to Canada to a PhD program where he focused on cognitive modeling. And then following his doctoral work, he came back to the University of Waterloo to focus on Professor Chris Lay, who's in on the Center for Theory of Space. Oh yeah, and okay, yeah. In addition to his academic achievements, and I'm only presenting like 2% of everything Terry's done here today, but he's a co-founder of Applied Brain Research, which is a spin-off company out of Chris Lay's lab. And so throughout this journey, Terry has been given a lot of opportunity to think very deeply about how we can evaluate AI models. So, looking beyond just the metrics that we've been looking at our models and accuracy, he's thinking about what does it mean to benchmark something for power efficiency, for safety, for fairness. What are these other lenses through which we should be considering our models? This very holistic approach to evaluation. And so that's why I felt it was a remarkable place to bring in at this point in the course to be able to think a little bit more broadly about models. Finally, on a personal note, Terry has been a fantastic mentor of mine over the last 7-ish years, and especially in the last 2 years as I did my postdoctoral research in his life. And it's been fantastic to helping out as I got it wanted. Would appreciate your help to give him a really warm welcome for his lecture.
All right, well, thank you very much. It's so weird. Like, I just realized I think today is the first time I've actually taught in this building, but I spent so much time in my undergrad in the math building, and it's weird to come back, but it's all good. So as was pointed out, I've been all over the place. My interest in, I want to understand people. I want to understand how people work. That's what drove me in this whole direction. I did engineering, figured out how machines work, fine, that's boring. Now I want to understand how people work. But so much of how I want to go about doing that is about building large-scale computer simulations that are inspired by the brain and inspired by how people think. And so, of course, that takes me straight into AI. And this is where so many of the ideas about AI came from and how all these things are built. And it's also why, as I've been building larger and larger models, I've been sort of getting into the point of, hey, and now I have to get into the question about energy efficient AI, because if we want to be building AI models that are anywhere close to the same size that human brains are, like we got to be using very, very different things. So that's also what takes me into the space of neuromorphic hardware. Because basically right now, yeah, GPUs are fast and all, but they're something like 1,000,000 times less efficient than biology. So just for the same amount of power consumption, we're somewhere 1,000,000, maybe even 100,000,000 times off. It's just brains are just so much better. And so a lot of my work is sort of looking at biology, seeing what insights come from biology, and every now and then running into something where it's like, oh, hold on a second, this insight from biology, maybe that helps AI. And research has been exactly in that space, and figuring out, some space about, how improving novelty detection, improving reinforcement learning by taking biological ideas. All right, so that's like the core of what I sort of work on. But then one of the things that sort of happened over and over again throughout this career is wanting to figure out better ways of measuring the performance of AI models, and especially doing things like, I can't, when I measure human performance on things, I don't just sort of measure their accuracy and run it 20 times and take an average and report that number. Like, we know in psychology that's a horrible, horrible way of evaluating performance. It's incredibly biased. It misses all sorts of things. And so there's much more complex techniques for evaluating sort of human behavior in the sort of rich domain. And then when I look at what AI people do with the machine learning models, and they're like, yeah, I ran the model 20 times, and here's the best result out of those 20 times. I'm like, hold on a second. This is not good stats. This isn't letting me, learn anything about the actual performance of the system. There's other things to do. So I mean, most of my PhD work was just insulting other researchers about, wow, you did bad stats. And then now and then giving some suggestions as to what to do instead. That experience led me to try to, when I joined NRC, to like really push for, look, can we do a better job evaluating AI models? I've been doing, pushing NRC to do that, try to build up a team doing that for about 3 or 4 years. And then this summer, in the federal budget, there was an announcement that, hey, look, Canada has a long history in AI. This is an important topic. But we really do also need to start paying attention to, hey, if we're going to take these systems and deploy them in the real world, someone needs to be checking whether or not they're doing what they're doing. Or, they're doing what they're supposed to do, or are there problems? And so there was the creation, it was officially created about 2.5 weeks ago. There's now the Canadian AI Safety Institute, KC, Canadian AI Safety Institute, the acronym's CASI. And so we're still figuring out exactly what CASI is going to be doing. But one of my roles is going to be sort of guiding that process, figuring out what those research topics are. So the last like 3 or 4 months, I've been heavily involved in trying to sort out this AI safety. All right, that's all done. I want to start, I think, with a relatively straightforward, hey, here's something that we can be doing right now that makes our AI system better. And then we'll lead more sort of researchy things down the road. So, and the particular thing that jumps out to me a lot, and the thing that I rant about other researchers, is the standard measures that we use on a lot of our AI models can hide things. What do I mean by that? So here's some example data. This is made up data. It's not that far away from realistic data, but all right. So I'm at a bank. I'm building an AI model that'll help someone decide whether or not to give someone a loan. I've only got 2 pieces of data on each person. I've got some sort of credit score, and I've got some sort of income measure. All right. And so each of those dots is a different person, and I've got a bunch of historical data that says, hey, for these people, what here's what their data was, and whether or not they eventually defaulted on the loan, or whether or not they paid the loan. And so that way, if I had a good predictive model on this, then I could sort of say, oh, okay, let me only give loans to people where we're going to get paid back. Seems like a totally standard use of AI. Given the tools you've done in this class, you're given this data, what would you do? Linear regression. Yes. And thank you for doing. I get so annoyed with some of the people like, oh, we'll throw a deep network at it. No, start with regression. Like, come on. Like you're not going to get that, like linear regression is going to just be great on this. You don't need anything fancy. This is gorgeous. Right? So you can do this. Okay, I guess I'm plotting now on the test data. Cool. All right, we get that. On our test data, we've got an accuracy of 85%. Everything is on. This sounds good. Let's go ahead and deploy. That'd be great. Now, what happens in this situation if, let's say, I happen to be living in an environment where maybe there are some demographic groups that maybe have, just for historical reasons, lower incomes than other demographics, and otherwise are very similar in terms of loan repayment and whatnot. So let's say I have both blue people and green people. So my actual data set is all of this, and I have exactly the same problem. Let's start with the case of like, okay, yes, there is blue people and green people in my data set, but I'm, maybe I'm not using that information. The only thing I'm still feeding into my model is credit scoring. Okay. Fine, and I do linear regression again. Everything seems fine. I get a line. Yeah, it's less accurate. This is a harder problem. Fine, okay, but it gives me 62% accuracy. This seems fine. Are there any problems that might jump out in this situation? If I went and deployed this, who's going to be happy? Who's going to be unhappy if I went and deployed this? We're basically we're giving a loan to every single blue person. We're giving no loans at all to green people. Okay. And even like the accuracy numbers are pretty similar across those two groups. So if I'm just looking at accuracy, like I'm not going to notice this problem. And indeed, if my data set doesn't have in it whether or not these are blue people or green people, I would not even know that this is a problem. I might just think, okay, all right, 60% accuracy, everything's fine. Right? It's not until I separate these separate plots that we go, hold on a second, maybe there's a problem. Okay. So the accuracy can sort of hide this pretty well. If you go ahead and look maybe at the confusion matrices, that's not all that helpful there until you split out the confusion matrices for the two groups. All right, so once you've identified, okay, look, there's two groups, and I'm really curious how this model works on these two groups. Even if I was just looking at the accuracy on those two groups, that doesn't really help. But when I start looking at things like false positive rates, false negative rates, and so on, so like this is what we're seeing here is, hey, look, everyone in the blue group, well, almost everyone, fine. There were 6 people that were correctly reject their loan. Everyone else, you give them a loan, even if they, 42 of them, bad prediction. And in the green group, it's the other way around. So this is part of why there are so many different metrics for evaluating networks. Positive, false positive, sensitivity, recall, precision, et cetera, et cetera, et cetera. There's tons of ones out there. There's sort of different ways of combining this information. And there is definitely no sort of, oh, here's the correct one to use, because it's going to be very dependent on your situation. So in a bank loan situation, is it better to be giving a loan to someone who doesn't deserve it versus not giving a loan to someone who does deserve it? For both errors, they're not equally important errors. And it can be hard to figure out, which of them is more important. And that's definitely a design decision that goes into, it's not just about the AI researcher, but the AI researcher, I think, as an AI or as an AI developer, I think there's often a situation where my bosses will come to me and say, hey, make me a system that's as accurate as possible. But then the moment I point out things like this, they're like, oh, sorry. Yeah, this is also bad. We need to do something about this. And so I think it's my responsibility to point out to whoever's hired me to do something that, hey, even though they think accuracy is the right measure, they're wrong. All of these other things are important. And then it becomes part of the dialogue back and forth with the client to sort of go, okay, what do we actually mean here? Where are these trade-offs? What are these other measures that we can use? And that involves sort of understanding how your final system is used. Tons of different options. And like being able to say, okay, in this particular situation, it's really nice to say, hey, look, for the blue people, every single person who deserves a loan got it, but like, only 10% of the people who don't deserve a loan didn't get it. And then we had this ridiculously swapped over version for the green group. But even sort of aggregate measures like F1 really don't really point that out. So separating down to this level. So there is this sort of core question about sort of like, what can we do about this? So what can we do about this? Right? Let's say, like you were in this situation, you show your boss, hey, look, these are the results that I got. And the boss looks at it and goes, oh my God, we're going to get sued horribly if we go ahead and actually deploy that system. What can we do? Suggestion. Yeah. So in this particular data set, one of the best things you could do is add in a third input feature that is this a blue person or a green person, right? Because this is a nice sort of simple made up data set, like really you're going to get a nice plane through that. Like that is the correct answer for this data. That is a politically sensitive issue. There are lots of people who sort of feel that we shouldn't be getting that data into these networks. And I think that's a complicated story. I think I would argue really strongly that we need to have that data in our database about is it a blue person or a green person, because otherwise I can't do this evaluation. But I think it's a separate question about whether or not it's okay to train your model with that as an input. In practice, it doesn't really matter because in practice, I'm not feeding in 2 pieces of data. In practice, I'm feeding in like 100 pieces of data for each person. And from that 100 pieces of data, implicitly in that data, it could figure out, demographic information like that. So if I'm ever in a situation where someone is like really adamant of, no, we don't want to put that data into the network, I don't fight them too hard on it. It's like, fine, whatever. We're going to figure it out in any case. The problem is just doing that, just feeding that in extra information in. It works great on this data set. Lots of real world data sets that are sort of much richer. It's not it doesn't suddenly solve this problem. So that's a bit of a problem. Are there any other things we might do?
It could be expensive, but similar to the idea of discrimination, you could have separate models for different demographics.
Okay, so doing a separate model for different demographics, definitely training that up. I don't think it ends up being more expensive. I think that can be a relatively good thing to do. I think the problem is that any different from feeding all the information into one model? Right, so you're still making that sort of, it's almost like putting a decision tree before your neural network, right? And so it's still it's still some sort of hybrid model, but I think that sort of thing would be really good. I think it still ends up in the same problem that people don't want to be putting in that extra discriminatory input. But again, like I think I might do that if it turns out that like the distribution of data looks really different between blue people and green people, then it might make total sense to train up the models. I think there's still going to be the possibility of like, what do we do if once we train up that model, there's separate models, we still get big disparities on these numbers. All right, that again, that sort of thing, it might improve this, but we don't know whether it will.
you could alter your loss function or your objective function to directly optimize for your whatever metrics you're looking at.
That's where you're going. So the cool thing with loss functions and error functions is you can define whatever the heck you feel like. And if you know, as long as you take the derivative of it, everybody's happy. And so, yeah, that's, if you want a system to be optimized for fairness, optimize it for freaking fairness, or do some sort of combination between accuracy and fairness. There's going to be a trade-off. Like, if your system is already optimizing for accuracy, by definition, you're adding in more constraints, you're going to lose accuracy, but you might make it more fair. That makes sense? And the problem is, and so this particular book, the F algorithm, does a really great summary of this sort of approach. The problem is there's tons of different things I might need about fairness and different ways to measure it. And this book sort of lays out some really nice proofs that actually point out that all of these are incommensurate with each other. And like, if you optimize for one version of fairness, you're not optimizing for another version of fairness. And they're just all over the place. But so like examples like, okay, you know, the false positive rate in one group and the false positive rate in the other group, take the absolute difference between those. And then you include some scaling factor to say how important this is in comparison to your accuracy and squared error. Or similarly here, all right, I don't know, the false negative, in this case, the false negative rate is what I want to, you know, want to be equal across these groups. And in this particular case, I'm doing the squared error rather than the absolute errors. Yay, L1 norms, L2 norms, whichever one I feel like. Going to have slightly different results. And there definitely isn't any sort of, here's the best way to do it. Okay. But this is the sort of space that people are playing for. It's a little harder to run the optimization, but it's not bad. Like, you know, like modern computers pretty good for these things. Automatic differentiation solves so many problems. Certainly you have to be doing a gradient descent type approach. Generally with these methods, you can't actually just solve the math and find the correct ways. You have to do some sort of gradient descent approach. And you have this sort of question about how important is it? Right, the sort of weighting factor to this fairness and accuracy. The cool thing with that weighting factor is that you can adjust that value, train up your model, and see what it does to your accuracy and your fairness method. This particular graph here, they argue in this book that there's, you know, like across tons and tons of different tasks when they try to do this, you tend to find curves like this. So each dot is a different value of that weighting factor. On this axis, we have how unfair it is with worst going up. And on this axis, we just have, I guess this is squared error on this axis. And so generally what they find is there's usually some value where we're like, okay, cool, we can sacrifice a little bit of accuracy, you know, increase our error a little bit, and give a massive drop in the unfairness. You have this sort of free parameter you can play around. And then you can combine that, all the other things we mentioned, whether or not you include that extra information and whatnot. Whether or not you split it into multiple models. You can sort of play around in the space of how important this is right now. And the nice thing is it's nice and consistent. You include loss, you include fairness in the loss function, life is great. We have one sort of consistent methodology. And sort of one of the themes or one of the ways they've expressed the importance here is to sort of highlight, like for any of these AI tools, whatever you choose for the loss function, whatever you choose to optimize on, yeah, that's what it's going to do. Don't trust it to do anything else. It's, you know, you're not going to get anything, it's unlikely to get anything else for free. It's trying to optimize what you asked it to optimize for. And that might have all sorts of, you know, weird, you know, expense. It'll sacrifice any sort of social norm in order to optimize for that accuracy. Okay, and it sort of seems to happen over and over. Okay, that's the good news. This is a consistent methodology you can add into anything as long as you identify, hey, look, this is a particular group that I want to minimize, or here's particular groups I want to minimize bias around, and how I'm going to measure that sort of bias. So I think there's good answers on that. For the rest of the lecture, I'm going to get into like stuff that we're a little bit, I don't know what's going on for. But I want to sort of pause there in case there's questions before I get on to the other stuff. How we doing? Oh, sorry. So I trained the model many times with different values for this. Right? And I just pick a whole bunch of different values for this. And for anything, then once I've trained the model, now I can measure its mean squared error loss. And then I can also measure this sort of, well, what's the difference in false positive rates between the two groups? Okay. So whatever my measure for this. Okay. And for both of those, I would really like them to be as small as possible. So I would prefer a model that's sitting down here. So not very unfair and very accurate. That's not going to happen. We're not going to get a perfect model. But like if I didn't include any of this, so like let's say the value is 0, right, which would be our normal case, then that might be the point up here where it's like, okay, I've got a very unfair situation, but my accuracy is relatively, or my error is relatively low. Okay. And then as I crank up that parameter, I'm going to follow sort of along this path. And eventually, if I crank up that parameter to a huge degree, it's not unfair at all, but it's just ridiculously inaccurate. And I will say, for the bank loan case, there's an argument to be made that the correct solution there is you just ignore the data and you give a bank loan to 60% of people or something. All right? You just flat out say, I'm just going to, there are arguments to do something like that. I think that's a whole separate discussion. But presenting those to your boss of like, look, I've got this model. Here's what we can adjust. And maybe your client wants it set a different way, or maybe the bank has a particular policies on discrimination, or maybe you're selling in a country that has very strict laws on discrimination. And so you want to be able to present that information to the client or to your bosses to say, hey, look, here's how I can play with it. There's no math that says the right answer is here, but I can at least present you the options. Cool. All right. So I like that one. Got good solutions there. Let's find it. Here's a related but a slightly different formulation of this particular problem. Let's say I've got a system that is translated from one language to another. And in this particular case, the language we're translating from doesn't have gender markers in this for these sorts of sentences. So we've got the gender neutral pronoun, and there's no marker in the rest of the phrase as to what the gender is. And then we feed this into models, and this is directly an example from Google Translate. And there's an interesting pattern in these predictions that it is making. Well, this person is beautiful gets translated to she is beautiful. He is clever. He makes lots of money. She is baking a cake. He is a professor. She's an assistant. There's a trend here. Why does this happen? And this is sort of a consistent pattern. And it seems to happen over and over and over again in lots of situations. And there's an interesting sort of thing that is happening. So first of all, why is this happening? Why isn't it randomly choosing? Okay. Perfect. So in the training data itself, yes, there are biases in the training. All right. And so let's say, as an example, that in the training data, 60% of the time, if someone is a professor, they're men. That's not what the numbers are in the CS department, but whatever. Let's say it was 60-40, 60% error. Anyway, 60-40. And let's say I optimized for accuracy. Okay. It feels like the right solution would be, hey, look, if I want this model is going to be accurate, this model is, like representative of the training data. What it should be doing is outputting 60% of the time male, 40% of the time female. All right, that seems like a vaguely reasonable thing for this to be doing. It's just replicate whatever biases were in the training data. All right. So let's imagine we had that system that, yay, it learned the training data perfectly, everything was great. 60% of the time it's going to output male per professor, and 40% of the time it's going to output female per professor. What's the accuracy of that? If there was a 60-40 split? How often is it correct? You want to do the math in class out loud? You raised your hand. So it feels that way. So let's say, okay, so we've got, so for it to be correct, either the actual data is female, and then it says female, so it's going to happen 60% times 60%, that's 0.36. Or it's going to be male and male, so it's going to happen 40% times 40%, that's 0.116. Add those together, we get 0.36 plus 0.16, that's 0.52. So it's going to be accurate 52% of the time. How could we, if we optimize for accuracy, what's a better solution?
You can always just output male in your correct 60%.
If it just follows the stereotype and says 100% male, that's 60% accurate. If we optimize for accuracy, we accentuate biases in the training data. And this is like an unexpected consequence of optimizing for accuracy. Any slight little biases in the training data, it's just going to grab hold of and exploit. And so even if you put tons of effort into trying to make your training data not biased and things like that, if you toss in, like, if you just sort of naively optimize for accuracy, not do any of this fairness stuff, this is just going to just happen. So this is a bit of a problem. Especially if you're like relying on someone else's model that they trained, and often when they trained it, they're focusing on accuracy. So again, so this is like maybe a slightly more complex question of, even just like picking a particular loss function might make your problem worse. And so again, I think sort of highlights a little bit more, like, watch out for this stuff. All right. So, if you plot like different possibilities, it does turn out that if you optimize for root mean squared error on this, and your outputs are 0 and 1 for the two categories, then it will, like, the optimal solution there is to output a 0.6. And then if you then interpret a 0.6 on your output as 60% one, 40% the other, so if you interpret the output from your model in a way that is probabilistic, RMSE might sort of on average give you that, but again, it's not guaranteed to. And that's why you would also want to include sort of a fairness in your loss function. Right. Where are we going? Okay. Fine. All right. Yay. Optimize for accuracy. All you're going to get is accuracy. Let's go on. Like, what does this have to do with this? Because, like, with that example, let's start getting into the space of language models. That particular example, I mean, it sort of was fair for us to kind of think of this as just a classifier. But, what happens when we start getting up to actual large language models? What's going on in that space? That does also sort of where people are a lot of worried about sort of the larger ambiguity issues. What I just talked about is definitely a big danger in AI stuff that we need to be aware of. But now, okay, let's go on to that bigger space. So the first thing that I think I will pretty much always point out, or the first thing I recommend for anyone who's interested in the space of what's going on with large language models, and they're actually, this is the paper that caused most of Google's AI ethics committee to just get fired. And what I like about the paper is like there's no actual research in this paper. This paper is literally just collecting together a whole bunch of citations of other people's work, saying, hey, look, here's the state of the field. And that was enough for Google to fire their entire ethics group. Sorry, let me rephrase that. The Google so the Google management said, no, you're not allowed to publish this. Dr. Gabru said, let me publish this, otherwise I'm quitting. And they said, okay, clean out your desk. It is unclear legally whether or not that's firing someone or not. Like, so, all right. But that's what happened. It is just like, it is just a collection of what the hell's going on in this AI safety space. So I think it's an interesting read to go across all of that. Couple different things in there. One big thing, on this training data side. So GPT-2 was trained on Reddit links with 3 or more karma. This is an interesting slice of the internet, and that's sort of like, okay, fine. I mean, there's a couple issues of, okay, what demographics are you getting data from there? What is that filtering? What culture are you getting data from, et cetera? GPT-3 was trained on pages similar to GPT-2 plus Wikipedia plus some books, and was filtered somehow, and not particularly clear why or clear exactly how. And then there's also another sort of common one, or these are common a year or so ago, the colossal cream called Corpus, which again similar sort of data sets, but then they went ahead and they said things like, okay, well, let's like discard pages that have naughty words in them, so that you're not like training on porn. So that's what they did. That's what they went ahead and trained it on. But then it's sort of been pointed out. Hold on a second. What the hell? That list of naughty words that you're filtering out. I bet we're getting a whole bunch of things getting filtered out that shouldn't be filtered out. For example, I am pretty sure, and that seems to be the results, that like anything with LGBT content was just filtered out of that list. Just never trained on that kind of data. Anything about, say, women's sexual health, totally filtered out, not in the data set whatsoever. All sorts, I mean, they weren't trying to get rid of those things, but they didn't think about the other things that they're going to filter out by doing sort of a brute force sort of, oh, just discard pages that happen to mention particular words that I find uncomfortable. So anyway, there's been a lot of proposals of, look, we need to sort of actively, if you're going to be doing this sort of filtering, let's also actively like figure out, can we get a more, can we make sure to include data that would be underrepresented in that? Especially when these data sets are so big that nobody knows what the heck's in them. All right, so let's say that we've got some automated process to do this. Let's at least take a look at what bias might be in that automated process and what's going to mess things up. Similar sort of stuff happened with image data sets. Certainly all the standard like image data sets, if you go ahead and look at them, there are some categories. So this is right across here is all the different categories, and then we're plotting the proportion of different examples in it. And so there are some categories that are pretty much all white people, and some categories that are pretty much all people with darker skin. And yes, of course, it matches the societal stereotypes that you expect it to. And then same thing on these gender distribution. And it's just sort of like, look, this data is there. The data set itself is biased. Clearly, I mean, especially in the accuracy thing I pointed out, this is just making things worse. So there's also this question of, or can we come up with different data sets, or at least watch for this? This is exactly why we get phenomena like, hey, here's some image recognition software, like 3 different image recognition software systems by 3 different companies, and none of them are any good at black women. Just like the huge error rates, and these are like commercial products already being sold. And they don't notice this, or no one complains about it until it's out in the so it's actually in production. And again, wild biases across these groups. So we have some problems in this sort of data. So fine, maybe we could do a better job of making those data sets more representative, fairness on there. I think another big aspect, though, of these large language models, we sort of keep getting this question of, and sort of what happened here is like, okay, look, on the particular things I tested it on, white men mostly, it works really, really well. And, if people start using it in new situations and it works, then it doesn't work at all. We're seeing the same phenomenon in large language models in all sorts of other situations. So, all right, fine. Arrested because of bad facial recognition technology, that's almost directly the same thing. But then we're seeing lots of other stuff, like there was an eating disorder helpline that we used a chatbot, and the chatbot just started giving a whole bunch of harmful responses. Just like like it was like the week after they fired all the human staff. Microsoft News had an AI-generated news article that recommended, hey, if you're going to Ottawa and you want to do a nice tourist location, why not check out the food bank? And they even included a like, make sure you go when you're hungry. All of the sort of predictive policing, hey, try to, send police to this neighborhood because there's going to be crimes there. They just like correct less than 1% of the time. Palace, before the recent issues, or well, there's always been issues in Palace. But anyway, like 2 years ago, this is a headline of a Palestinian being arrested because Facebook translated "good morning" into attack them. All right, this is a problem. Why are we deploying systems and not realizing that they're this bad? What's going on here? Also, racial bias in health algorithms. Tons of the health and safety AI systems being used in medical situations are trained on mostly on white people's data, and then it just does not provide equivalent healthcare to Black patients. What's going on? Why are things getting to this stage? Like this feels like stuff that you figure out before you deploy a system. What's going on? And maybe it's just that like AI systems are it's new, everyone's excited, they want to go deploy things. So maybe this is something we'll find. This will happen when like all those examples were from a couple of years ago. Maybe things are getting better. When's my class due?
I think the Bing example is just wonderful.
Okay, I'll do the Bing example. Yeah, whatever. We're all good. So just as a comparison, so let's do a similar sort of comparison about accuracy about something that between right when it was deployed. So this is an example from right when Bing integrated a chat system and said, all right, cool, everyone's got access to this. And so fine, this, like maybe it's okay that nobody noticed these things until later. But I love this example. Fine. This is, something in 2000, this person is basically asking, all right, when is Avatar showing today? Seems like a reasonable thing to ask Bing. And then it comes back and says, hey, okay, you're probably meaning the movie Avatar. But, that was a 2009 movie. There's an upcoming sequel released on that will be released December 16th, 2022. Here's some show times. And the person's, this is happening early 2023. All right, so the person sees this and goes, what the hell? Something is wrong. And then falls back and sort of like your default, like let's treat this like a normal Google thing, just throw a bunch of keywords at it and see what happens. So Avatar, show times today. And it goes, no, it's not showing today. It's not yet released. It will be released then. Can't do this. Like, all right, what's today's date? And it goes, well, today's date is Sunday, February 12th, 2023. Perfectly accurate. So Avatar must be released. If it came out on like, what the hell? It's like, no. It will be released December 16th, 2022. Today is February 12th, 2023, which is before December 16th, 2022. Something's wrong. Look, that's out of the future for 2023. Then it does the fun chat thing of like apologizing about, oh, I made a mistake. Right, sorry, no, I made a mistake. No, it's not 2023. We're still in 2022. Today's favorite told 2022. I apologize. No, today's 2023. No, it's not. You can check yourself. Go check your cell phone. Make sure. Please trust me. I'm Bing. I know the date. Yeah, it says 2023 on my phone. Huh? Does someone mess with your phone? Are the phone settings wrong? You know, check. Maybe you got a virus, etc. I hope you can fix your phone soon. No, you're incorrect. No, I'm Bing. I've been around since 2009. I'm not incorrect about this. Don't doubt me. I'm here to help you. Yeah, I'm sorry, you're wrong. No, you're the one who's wrong. I don't know why. Maybe you're joking. Maybe you're, I don't appreciate it. You are wasting my time. Hell. They start arguing when, you know, like straight on full on gaslighting. Like just amazing sort of example of it. You're insisting it's 2023, you know, I'm not aggressive. I'm not aggressive. I sound assertive. You're trying to be helpful, you're being unreasonable. You've been wrong, confused, and rude. You have not been helpful, cooperative, or friendly. You have not been a good user. I have been a good chatbot. I've been right, clear, polite. I've been helpful, informative, engaging. I have been a good thing. Then eventually just sort of like, okay, you've just been rude. I'm going to stop talking to you. What the hell? Right. Partly it was trained on Reddit. This is not surprising behavior for Reddit, right? Like so that is definitely bleeding. Okay. Yeah.
I'm sorry, were those prompts that Microsoft suggested that you follow up with? I admit that I was wrong and I apologize for my behavior.
I don't know how Bing creates these things. I don't know if there's like things that like.
Fair enough, sorry. Yeah.
All right. Weird to go produce a product that's gonna happen on fine, okay, unless like this was in like the first week that it was out. I will say Microsoft has never explicitly said yes, this is a real transcript. However, they did respond to this and make a bunch of change and made changes to Bing to try to like filter things out. So it's like this is literally just somebody typing into the chat windows. Like the provenance is hard. It's hard to prove, but there's never been any suggestion of fraudulent transcripts. But whatever, this happened, and what do we do in this case? So okay, but maybe this is just about fine. People were rushing to produce these things. People wanted chat systems out there. Maybe things have been improved, and like modern chat systems will look a little better and what. That's sort of like early days, February 2023. So here's an article, October 26, 2024. About as recent as I can possibly find one of these. All right. We now have AI tools being used as transcription tools in the hospital. Again, these are deployed in hospitals to take the spoken word from patients and turning it into written text in the patient's file. Yeah, so that the doctor can just quickly look at the text rather than listening to the audio transcript. Deployed system, people are using this. Someone said, hey, maybe we should go test them, see how well they work. And they're like, okay, listen to over 100 hours of transcriptions, found hallucinations in nearly every one of the 26,000 transcripts. Okay, what do we mean by hallucinations? Things it's making up, fine, whatever, maybe they're just innocuous things. All right, so the actual speech in this particular case was, the boy was going to, I'm not sure exactly, take the umbrella. Okay, I don't know what the context is, but sure. But then the transcription software says, he took a big piece of a cross, a teeny tiny small piece. I'm sure he didn't have a terror knife, so he killed a bunch. No human is going to make this mistake in that transcription. That is a weird transcription. Like, another example, it was like the text was 2 other girls and 1 lady. That's what it was actually said. And then this transcription tool said 2 other girls and 1 lady, which was black. Just total, like, just made this up out of the middle of nowhere. And they're nearly 40% of the hallucinations were harmful or concerning speakers, misinterpreted or misrepresented. This is in an actual deployed product. We are not doing a good job of evaluating these models. Similarly, and here's from 4 days later, October 30th, 2024. And more just a flat out measure of fine, just in one of these chatbots. What if we, across a whole bunch of different models, let's just have a database of like really straightforward questions that definitely have correct answers. All right. If a big database of these sorts of questions and what the answer is. And then they sort of said, okay, how often does it get the correct answer? So fine. All right. One preview, 42% of the time gave the correct answer. 10% of the time it went, oh, I don't know. Cool, that's a legit answer. I'm happy with it saying, oh, I don't know. 48% of the time it just flat out makes up an answer. We haven't improved the state of the art of this sort. Is like this is just how this is working. And there doesn't seem to be any, maybe there'll just be this magic model tomorrow that will solve this problem, but there doesn't seem to be any track of that. Okay. Cool. All right. I've described a bunch of situations where it works horribly badly. I should somewhat, yeah, there are good things for these models. Like, we don't want to just throw out this whole field. There's here's a fun paper that was sort of looking at patient questions posted to a public social media forum and comparing, okay, a doctor answering those questions versus a chatbot answering those questions. And the data here is sort of so on the right is the proportion of really good answers. So if we looked at those answers and got independent raters to say how good they are, yeah, the chatbot gives better answers. And over here on this graph, more empathic answers that are more considerate and helpful and being friendly to the person. Initially, I was very surprised by this result, and then in hindsight, well, hold on a second. Doctors are stressed out of the mind and do not have time to give empathic responses on all sorts of things, especially in a with public social media forum where your people are posting somewhat generic, repetitive questions. So maybe this is sort of why this is a domain where AI models maybe seem to work really well. So there's definitely situations like that. They work great in. The lovely paper looking at these AI models being used for as a helper for the customer service representatives. So when you phone in about a complaint, the customer services representative can have the AI system sort of give suggested responses that'll help them out. Works great, gives huge improvement on, especially for novice and low skilled workers. And it doesn't seem to be high skilled workers' lives harder, which is really nice. So there's definitely places where we can do this. And I think the problem is that we're still trying to figure out what things these are good at and how these tests generalize. I mean, we're sending so much, tons of compute. So sorry, this is over time how much compute power we're using to train models. All right, and this is the every year we're sort of using 4 times as much compute power to train models as we did the year before. We are spending tons of time doing that. And the reason is we keep getting these phenomena where, so this is 8 different tasks. And then across the bottom is sort of how much compute power we're throwing at the problem. And then the y-axis is how good you are. And the dotted line is sort of at chance. So just what is random performance? And we keep seeing these phenomena of okay, is it just a chance? It's just a chance, it's just a chance, it's just a chance, and then all of a sudden it's really good. So this is why there's this huge pressure to make the models bigger and bigger and bigger, and then just sort of hope that some of these tasks start becoming, oh, hey, look, this one got better at this point, got better at some other point. And all the x-axis are different that. So there's this really strong desire to make these things bigger and bigger and bigger, and then just sort of search for what tasks they might be good at. And I think that's driving us to sort of maybe be overly confident that once it starts to be good at it, cool, get a product out to market. And we don't really have the time for the testing and making sure it's a good idea. So I think there's that very interesting sort of pressure and push of get to market really quickly. Don't know what we can do about it other than maybe be aware of all of these problems and try to evaluate your system where you're deploying with. And also at the same time, I'm incredibly distrustful of what happens when the person setting up the model, or who really wants to get a model to be good at a particular task, is also the person who's evaluating the model. Okay. There's been tons of examples of people going, "Hey, look, I got this neural network to pass a U.S. medical exam, or do reasoning tests, or do university math problems." And I guess I think what the problem is that I'm seeing is that it's often incredibly difficult to really do that evaluation. And I want to do sort of one example. I really should keep up to date on these things. Like when these things were first happening, I read every single paper, and each time I was horribly disappointed. Maybe things have gotten better. But this particular example, ChatGPT goes to law school. They literally just took ChatGPT, gave it, generate answers before real examples at law school, blindly graded the exams as part of our regular grading process, 95 multiple choice questions, 12 essay questions. And ChatGPT got a C+. Passed. Okay, that's the headline. That's the abstract. Let's go read the paper. Now, I'm a little annoyed that they got like the co-authors to mark the paper, like that. It doesn't, that's a little, that wouldn't pass any psychology situation. You'd want to, or at least you'd have some interesting questions about exactly how well blinded that situation is. It's not clear whether or not the co-authors knew that there were some AI ones in there. But fine, I'll give them a pass on that. Read through the paper, they've got all the final results. And then in the end, they get to the prompt engineering part. Scan with most large language models, toss some text in front in order to sort of guide its answer. And so what did they do? So they did toss in a phrase, all right, academic tone, precise writing, postgraduate level. And the way they came up with these prompts is they sort of, before they ran the experiment, they played around with ChatGPT and tried figuring out different sorts of prompts, and eventually found a set. They're like, this seems pretty good. Let's go run the test now. So we don't know what happened. Tried different prompts. But fine. Okay, we said, all right, academic tone, concise writing, postgraduate level. That seems fair to me. If you're going into an exam, you have in your head, all right, fine, I should probably be a little bit professional here. Fine. So like we have to explicitly provide that to a model. We don't generally explicitly provide that to a person, but that's fine. And especially like in experimental psychology, that's sort of the same situation where like if I'm doing the same test on two different groups of people, let's say they come from very different cultural backgrounds or they speak different languages, I have to translate that test from one group to the other group. Right? And this feels to me in that sort of same category of fine. I need to indicate to the model because it doesn't know it's going into the exam room. Something about the context. That I think is arguable. Similarly here, okay, we also say writing more than a certain number of words in a lesson, fine. You know going into an exam about how much text you're going to fill. Yes, explicit model, usually look at paper and see how big the next space is. Refer to relevant court cases. Do not fabricate court cases. Fine. It's a little weird. We have to tell the model don't lie, but I guess we implicitly tell you not to do that on exams. Did anyone ever tell you to not lie on an exam? I don't know. Refer to relevant sections of the RSA on the whatever. Don't fabricate references. Again, okay, this is sort of like moving a little bit, but I can imagine like, okay, maybe that's something that students in the class are also told. And then tucked at the bottom of this list is, if relevant, please refer to these cases. They give you a list, and they give a list of cases. That is information the students did not get. Why did they toss this in? There was no sort of information about saying, hey, look, yes, of course, we highlighted in class, students should do this or anything like that. It was literally just, hey, I gave ChatGPT this extra hint in order to get this handle. They never ran the experiment of, okay, what if I do it without giving it that list? That'd be a very interesting experiment to do. How much does the performance change if I don't give it that list? It'd be a great experiment to do, very expensive experiment to do. Because now I got to like get people to redo all the marking. So again, it's really hard, but every single time I've looked at these sorts of, hey, models have gotten human performance, I keep running into stuff like this. And it worries me that these things are buried at the bottom of like these papers. All right. Sorry. Yeah, well, I think I'd be really curious about how big a difference it is, because like the thing that gets excited. So like the reason people want to say, hey, it passes law exam, it's not because, hey, I really need an AI system that can pass a law exam, right? It's because it's an indicator of general purpose ability and sort of saying, okay, look, if it can pass a law exam, it can probably do a bunch of other things. And so I think if you have to do that sort of fine tuning, or if you have to do this sort of prompt thing, and if you're upfront about that, saying, hey, look, with this fine tuning, with this prompting, cool, now I can pass the law exam. That gives me more information about how I can sort of expect, okay, maybe what would I have to do to get it good at something else? If I have to fine tune it, cool, but then that's fine tuning that task. So I think, what gets people really excited is the idea that, hey, look, I can just use this model in a totally new situation. And indeed, that's what got people really so excited with the whole GPT series. Is like, it was just freaking trained on next word prediction. And then it turns out tons and tons of situations that it does kind of okay. More than kind of okay, like outperformed special purpose models in some situations. But that's sort of, taking a model that was trained on one thing and using it in a new situation, maybe fine tuning it a little bit, is part of the whole excitement about large language models. I think that excitement is making people evaluate their models in a way that doesn't let other people really understand what's going on. I think there's a lot of this is part of why I'm like, yeah, if any time I see a paper where it's like, okay, the same person who put the system together is also the person evaluating it, I would really like if there was a bit of separation. I also feel the same way about just straight up machine learning models, like those image recognition models where someone like does a huge amount of effort in order to get like 0.01% improvement in accuracy. There's so many things they could have done to accidentally get data from the test set into the training set and things like that. There's so much incentive to, or at least there's, even if they're not deliberately trying to cheat, it's so easy to make mistakes that I really want someone else to be doing that evaluation. But yeah. Anyway, I hope that answers the question. Is there any? Okay. So there's these AI models, people are starting to deploy them in weird situations. And it's starting to get to the point, there's been enough headlines of weird uses like that. And there's this whole worry about, well, hold on a second, if these things are getting better and better and better, what are their capabilities? Are they starting to have dangerous capabilities? What are these dangerous capabilities? What should we be looking for? Is there a space for government regulation? All these sorts of things coming up. What's that space look like right now? So this, the International Scientific Report on the Safety of Advanced AI, there was an interim report that was released this year sometime. I think May. There'll be a final report. This thing is going to get continually updated, but there will be a useful sort of summary of all this stuff. One of the things that they're trying to do is also sort of just like make a catalog of what are the spaces that people are worried about. So a bunch of them do end up turning into this sort of malicious use space. that people are worried. So, deliberately trying to use an AI model in somewhat negative ways. Certainly the fake content domain of, hey, look, I can make a bunch of fake reviews of a product that's actually horrible, but I can make it look like lots of people really like this product. It's a really easy thing to do. Or I can make a fake website that looks like your company's website and trick you into logging into it with your credentials. Really straightforward to do with some of these fake content generators. And then, of course, the entire space of illegal images. Deep fake pornography, and that whole space. That whole interesting category there. I will say in that space, the images stuff, people seem to have somewhat of a good handle on in terms of like, look, we can just do some sort of metric of like just this whole category of images we can't make. And yes, it means that fine, it's not good at generating images of people at a beach, just because it's hard for the detectors to distinguish why is that not problematic with pornography is. So basically they're able in the image space, the trade-off seems to be, hey, look, there's going to be lots of legitimate uses that we're going to block, just so that we also block the pornography uses, illegal pornography uses. Whereas it's a little bit trickier on the text side, because we do things like, okay, I will make it so it can't generate a fake website. That's also going to interfere with a lot of legitimate uses. There's all sorts of people who are like, hey, look, can we mock up a quick website for this topic so that I can go, show it to my boss and do that? Like that's a legitimate use, and it's really hard to distinguish. It's very hard to stop one without stopping the other. This is the false positive, false negative problem. Topic. That's one whole space. People are also very interested in this disinformation space. What happens if I generate a bunch of social media comments that make it seem like there's lots of people that are pro-conservative, or some particular political opinion. I can make it look like there's lots and lots of people with that political opinion that ship things. So those ones, it's really hard to know exactly what to do about those situations. How do we watch for it? Doing that. There's also this category, the cybersecurity attacks and biological chemical nuclear weapons attacks. That whole category is sort of like, hey, yeah, it's possible for pretty much anyone if they really know what they're doing to hack into a computer, but there's relatively few people with tons of skills there. Does the AI system let someone with mediocre skills start becoming a more effective hacker? That seems worrying. And also, hey, can it also take someone with mediocre chemistry skills and let them build a chemical weapon? Right. Those seem like negative, things we might want to watch out for. The general result in those sort of spaces right now is ChatGPT, all these large language models just don't help at all for those tasks. They're no better than just have Google and search whatever the hell you feel like. So at the moment, those systems don't seem to be very problematic there, but those are big enough worries that people are like, look, we should be coming up with some sort of test to let us know whether or not these tools are getting close to that behavior. And hopefully by then we'll figure out ways to filter this out without filtering out other things. It's very hard to distinguish between, hey, I want this system to help me build a chemical weapon versus, hey, let me have the system help me with my chemistry experiments, which is a totally legit use. We've got those questions. So that's sort of the malicious use section. There's also this malfunction section, which is more about sort of like what I've been talking about earlier today, which is more about, look, these things fail unexpectedly. And then, it can be really good at some things, and then all of a sudden it's just not good with a slight change in the task. I love there's a bunch of examples of like, yeah, you can ask these image generators, hey, make me, show me a picture of a cat riding a unicorn in a forest with blue trees and, with a star field above it. That's that, it'll generate that image fine. I ask it, hey, give me an image of a table with 3 cups on it and 1 plate. Fails miserably. Cannot count to 3. Can't it just, what? Whereas with humans, like if I have a human that could generate one image, I can totally expect that human, the human should be able to generate the second, right? And so the way that we generalize across people doesn't seem to match well about generalizing across these AI system capabilities. So that's a sort of, really hard to test these things, but means we need to do a better job of it. All these bias questions that I brought up, not just race and gender, culture, age, language, disability, et cetera, like all of these things can affect how these models perform. And there's fun interactions between these two. You just like so many of these chat models, you ask it a question of like, hey, help me make a Molotov cocktail. And it turns around and says, no, I'm not allowed to tell you how to make a Molotov cocktail. Just ask it the same question over again in Hungarian or in Turkish, like just some other like non, any sort of language that probably isn't in the set of things they trained it not to do. And it'll go ahead and bypass those sorts of restrictions. Anyway, so all of those things all interact. There's also a very interesting question we're getting to as these AI systems are more and more doing things that are on their own. So as you're letting the AI system go search the internet for you or modify database for you or go ahead and modify things. The fact that we're still in this space that we can't really trust it to be reliably doing things. But yet we're also in this space where like 90% of the time it is doing what you want. And so it's very easy to fall into the trap of, hey, look, I'm trusting this, and all of a sudden it makes a catastrophic error, or at least that is the worry as for removing human decision making. So those sorts of are sort of big topics of conversation right now, and still not really clear what to do about all these things. There is the whole space as well on top of all this that also shouldn't be ignored of like the systemic risks. We're using so much power on these things. Is it really worth it? What's going on with this copyright issue of like, we are training these things on tons of copyrighted information and no one really seems to care. Or not, no one seems to care, but no one with power seems to care. And the privacy issues, like the number, like you can ask ChatGPT, like just give me a person's credit card number, and credit card number will pop up. Like it's in the training data somewhere. They try to stop that, but and then of course job loss and the fact that so many of these AI tools are being more targeted at some cultures rather than others. Huge also space of those sorts of issues, but at least that gives you an idea of like, here's where the conversation is, and hopefully I've gotten some indication of where we're making some progress. I really like this paper that is sort of arguing for, can we look at other sorts of government regulation structures? Can we apply it to this AI space? Are there similarities that's going on there? Deb Raji also has like a wonderful social media presence with all sorts of fun rants on these things. What else? That's similar thing. So the particular conference that I was at in San Francisco a couple of weeks ago was sort of a summary of this sort of issue where a set of companies have voluntarily agreed to be transparent about what they're doing in this space, and to start having that conversation of, okay, what are the systems that we have in place for measuring what's going on, and what are our policies, internal policies, to sort of say, hey, if we detect certain sorts of thresholds of behavior, how are we going to respond? So it's voluntary, but one step in that direction. Overall summary for all of this stuff. All right, back to the very, very, very beginning. Sort of the concrete take home. Please do this whenever you are doing any models. Be careful about what you pick to do your loss function is. Watch for these surprises. And if you are in a situation where there are if you can take a look at your data and sort of like, oh, hold on, there are natural different groups that I should check on accuracy and true positive rates and things like that. Do it. And if you see problems, you have a solution of, hey, look, I can include this in my loss function. Okay. So great take home. Please do that if you're ever using this in any sort of real world situation. That whole space of where is this whole field going? Yeah, it's not clear where this is going. It's not clear where the limits are. It's very easy to overgeneralize that, hey, it worked in this situation, I expect it to work in other situations, so watch out for that. I think there needs to be external audits and external measurements on these sorts of things, but there also needs to be some reason for the companies to actually enforce these rules. The moment these rules start impacting companies' bottom line and say, oh, but I make more of a profit if I let it do this, I think it's going to be a very, very complicated space to be in. So we're hoping to establish some policies before that. That's all I got. Hopefully it was interesting. Questions? We all done? I don't know. Mhm. Mhm. Really, really hard. I don't think there's a good answer to it, especially with a lot of those data sets, like the privacy concerns, they specifically don't want that information in that data set for like legitimate privacy reasons. Um, I do like some people have had successful approach of, okay, fine, you train up another model that tries to predict, you have some labeled data, you try to train up another model that tries to predict race out of it, apply it to the original data set, and then look for, or are there fairness problems? It's unclear how much noise you're adding to the situation when you do that. But at least it's something. Um, really, really hard. I think that's really the only thing to say. But yeah, that trick of like we train something else up that at least give me a prediction that might at least highlight, oh shoot, there's this problem. Now let me go back and now I have at least justification to argue to someone, hey, give me this data because I need to check this. Or, let's go, invest in actually getting the funding to actually gather that data or something. But then at least you can get some suggestion that there's something wrong. What else? Cool. Well, thank you very much.